Everyone, I'm Andre Ferraz, CEO and co-founder at Incognia. And today I'm going to speak a little bit about zero-factor authentication and the application of location data and location behavior to meet this goal of frictionless security. So just a little bit of background on myself. I'm son of two computer scientists. So I started hacking when I was 10. So I have a lot of practical experience in security, very specifically. Did computer science, and when I was in college, I started doing research in IoT security. And at that moment, that was um, the biggest insight for me on this new phase of IoT, right? And as having every object around us connected to the internet. And I started thinking, because of my cybersecurity mindset, okay, what happens if someone hacks into our cars or our implants or the objects inside of our house, right? So I started thinking that the consequences of hacking could go beyond people losing money or people having some issues in regards to their online reputation, but actual physical consequence. So that was the big problem that made me decide to get into this area and to start thinking about new forms of authentication, especially thinking about the challenge of IoT, which is we're going to be interacting with multiple devices at a time, and in most cases without even noticing. So that's why I got into this space, and I'm going to share a little bit about my experience working with this here with you today. So before getting into zero-factor authentication, I just wanted to start with the problem, right? This is Paul Graham, one of the leading players in the startup ecosystem, and he tweeted this a few years ago. I found it pretty interesting, which is he was talking about his experience with authentication methods and payments on the internet, right? And he's right, and I totally agree with what he is saying here. So like we started with the old passwords. In most cases, we're still using this as an authentication factor. And in many cases, we only introduce more friction over time. So the passwords became more complex. We had to manage more passwords at the same time. We also had to add additional authentication factors because the password was not enough. And the reality is that the user experience has been deteriorated because of this, right? So I think the goal of everyone here in this conference is changing this, right? Is bringing new solutions that are going to replace the password and enhance the user experience while not reducing security, right? So this is the problem that everybody wants to solve here. And as we know, authentication has been this constant balancing act between security and user experience, right? And when it comes to zero-factor authentication, we believe that this is the holy grail when it comes to balancing security and user experience. So what is zero-factor authentication? Well, according to Gartner's definition here, first of all, is a form of authentication that doesn't introduce any friction to the user. The user is not required to do anything. And one of the approaches that Gartner recommends here is a rule-based approach, evaluating network, location, and device signals to provide a passwordless login experience. And another important recommendation is to use the CARTA model, which is continuous adaptive risk and trust assessment. So this means that you would be continuously evaluating risk, and based on that, you would decide if you need to introduce some friction or if you are able to keep the user experience the best possible while there is a low risk, right? So when it comes to mobile, the experience we have been having here, especially utilizing location signals to to provide zero-factor authentication has been pretty good. So when it comes to financial services apps, for example, we see that 75% of the top 50 finance apps in the United States already request location. And this is very good because this means that these apps will not need to request location again to the user to be able to activate zero-factor authentication, right? So the user experience is pretty simple. The app, when it gets downloaded, would show a pop-up requesting access to location information. And we're seeing a very interesting difference here in this situation, which is some of our customers are not asking are not being explicit that location is going to be used for security purposes. And other customers we have are being explicit, as we can see here with this customer. They are being explicit that they want to access location services for security purposes. In this case, they're phrasing it as protecting your account, right? And this is important because we see that the first group of mobile applications that are not being explicit about why are they asking for location signals, they're usually having opt-in rates between like 40 to 60%. So it's not that high, right? So you're not activating zero-factor authentication for the vast majority of your users. And for the second group, the group of mobile applications that are being explicit and they're being transparent with their users, we're seeing that the opt-in rates are much higher. So we have this case here of a challenger bank, for example, that was able to reach 93% opt-in rate. A major bank was able to reach 94.5% opt-in rate. And we're seeing that most of the apps that are being transparent with their users are being able to reach opt-in rates above 90%. So this is great because this means that for this user base that has accepted to share location with the application, they are enabling zero-factor authentication, which means that they're enabling a completely frictionless authentication experience. No need for OTPs, no need for passwords, no need for selfies, anything. So this is great. Like with one click, the user will opt in to sharing one piece of data with the mobile application, and from there they're able to experience total frictionless authentication experience. So how does it work, right? So it's pretty simple. Once the user authorizes the app to access this location information, this location information will be combined with other data, including device signals, so standard device fingerprinting, network information, and things like that. And then with this information, engines like ours at Incognia will evaluate these signals and will define if we should trust or not this authentication event. So in this case, if we identify that the user is logging in from a trusted location, from a trusted device, and also connected to a trusted network, we would say low risk. And in this case, the user would not need to do anything to authenticate to the app. And in the event we identify something anomalous, so we don't know that location, and the current location of the user is very far from the last location. It is impossible for the user to have moved that fast, for example. The device is new, is unknown, or is a device we're not able to trust because there is some bad behavior associated with it in the past. Same applies to the network. In this case, we would trigger step-up authentication. In this case, the step-up authentication would be the existing authentication flow that was already in place for that app. So if the app was already using a password, they would request a password. If they were using facial biometrics, they would use that. So nothing changes on the user experience for that user. But when we identify that the scenario is a low risk scenario, we would eliminate all of the friction from the authentication from the authentication experience. So here's a case study of a mobile bank that has implemented zero-factor authentication to their app, and the results are pretty impressive. So here, in terms of security, for example, we didn't have any report of fraud in more than 200 million logins that were enabled by location and zero-factor authentication. There was a reduction in fraud losses, very significant, 90%. And what's interesting here about this reduction in fraud losses is that the opt-in rate for this mobile application was about 90%. So actually, the remaining fraud losses were actually from the group of users that decided not to share location information. And one important thing to say here is that most people think about location as a way to find the bad actor, right? So as a way to detect the fraudster. But the thing is that given that for zero-factor authentication, you need high quality location information. To achieve high quality location information, you need to request the users to opt in to share this information. So you won't be able to do this with GPS. You won't be able to do this with IP information because this type of location data is very easy to spoof. It's not precise, so you won't be able to achieve zero-factor authentication with these signals. So given that you need the users to opt in, it's very hard for a fraudster to share this information with you. So it's unlikely that you will be able to detect and find the fraudster using location information, at least using high quality location information. So the thing here is that this is not being used to detect and find the bad actors, but to protect the good users. So once the user enables location services and shares this information with you, you'll be able to create this unique profile based on the location information. And this account will be much more protected because it will be very hard for a fraudster to impersonate this user's account, because this fraudster will need to emulate the location behavior of the original user, of the good user. So it's much harder for the fraudster to do that. So in this case, the reduction in fraud losses is actually because more accounts were protected and these accounts were not hacked by the fraudster. So the remaining fraud losses were from the group of users that decided not to activate zero-factor authentication. And then on the user experience side, we saw some pretty good results as well. So 93% friction removal. So it means that more than 90% of the users were able to experience zero-factor authentication. So they were not requested to type any passwords, OTPs. They didn't have to scan any fingerprints or faces. So it was the complete removal of friction for more than 90% of the customers of this mobile bank. And also the false positive rate was pretty low, below 0.01%, which means that very few users that were legitimate customers were flagged as high risk and had to experience some friction. So why does it work so well? So location behaviors are very unique to each person. To give you an idea, the chances that a random person in the population would be able to unlock your iPhone using Apple's Face ID is 1 in a million, right? The same probability for a person to be able to get access to your account using location behavior is 10 times higher. So it's 10 times higher resolution than Apple's Face ID, which is today considered to be one of the top facial recognition technologies. And why does it happen? Well, each person has a very unique location behavior. If you think about it, like you can live with your family, for example. You can spend a lot of time with them, but there are some moments in which you are going to other places by yourself or with other people, and this information is what enables zero-factor authentication and location more specifically to be so effective. So the way Incognia technologies work, as an example, is that for each location, we create a unique fingerprint, including these data points here on the right side, which are GPS, cellular networks, Wi-Fi, Bluetooth, and also the motion sensors from the device. And we create a unique fingerprint for each location. So for example, let's imagine that this place here, which is my house, was never mapped by our technology. In the moment I get here with my iPhone, we're going to recognize new signals, right? So we're going to recognize a new Wi-Fi router, new Bluetooth signals, and other things like that. And we're going to create a unique fingerprint for this location and associate it with my behavior, right? Over time, we're going to learn that this is my house because I spend most of my time here. I'm here almost every night. And based on that, we're going to assign this as a trusted location for me, right? So this is one of my trusted locations. This is a place that if I'm trying to log into my bank account or if I'm making an online purchase, this is expected behavior, right? This is a place that it is normal for me to perform these type of activities. So when we recognize that my phone is doing one of these transactions from here, we would say low risk, right? We would say you're able to authenticate this user with no friction. So this is how location works, and this is how the identities based on location behavior are built, right? So it's learning every time. And what is interesting and different from, for example, biometrics and other formats is that it is constantly changing, right? So as I'm moving, as I'm changing habits, this digital identity is adapting to it. So it's not static, and this is what makes it more secure, right? So an attacker in this case would need to behave as you behave. So they would need to do that for some time, right? So that alone makes it more complex, but also they would need to access some locations that are private and are harder for them to access. So they would need to come to my house. They would need to sleep here. I would probably notice that there's someone else sleeping at my place, right? So this is what makes it more complex. And spoofing the location information that contains all of these signals combined is much harder than spoofing the IP address or spoofing GPS. So it requires additional skills and data from the fraudster, which also makes it much more complex. So I'm not saying that this is like the holy grail, it's perfect, it's the silver bullet, because it doesn't exist in security. But it certainly makes the life of an attacker, of a fraudster, much harder because it includes way more variables for them to be able to manage, right? So it's a dynamic fingerprint. It's constantly changing. It requires physical access to some locations. The location information itself is very hard to spoof, and it requires some time to build an identity that is similar enough to my identity so they can impersonate my account. So it's certainly more complex for an attacker. And so on one hand, we saw here that location behaviors are unique, right? So from a security perspective, these location behaviors are able to deliver very good results. But on the other hand, what's interesting is that even though these behaviors are unique, these behaviors are also highly predictable, because even though we have our own sets of trusted locations, when we are performing these transactions, we're usually doing this from safe locations, right? So for example, one of the things we see here is that about 90% of the low risk logins to finance apps and 95% of the low risk sensitive transactions like changing a password, for example, or adding a payee happen from a trusted location. What does this mean? That the vast majority of the transactions happen when users are at places that are part of their lives, right? So it could be home, it could be their offices, their friends' homes, their parents' homes. So basically locations that are part of their routine. So our definition of trusted location is basically places that you go multiple times over your life. So this is one thing. Another interesting insight that is not here on the slide is that about 85% of the mobile banking accounts, for example, are open when the user is at home. So this is another interesting insight to show how location and the location context is relevant when considering a frictionless authentication factor. So we're seeing great demand. So zero-factor authentication is definitely gaining some attention in the market. In 12 months, for example, since Incognia has launched, we were able to grow pretty aggressively. So we're currently protecting more than 150 million mobile users in more than 15 countries. We're currently monitoring 1.5 billion sessions a month. So there's certainly demand in the market for this type of solution. As we know, there's a lot of demand for passless authentication in general. But I would say that zero-factor authentication and location applied to it, it's certainly gaining a lot of attention in the marketplace. And this was it. I hope you enjoyed it. This was a little bit of my experience with zero-factor authentication and location signals applied to it. If you have any questions, feel free to reach out. I'm very easy to find in the internet. You can find me on LinkedIn, but also feel free to send me an email. My email address is andre@incognia.com. Feel free to reach out with technical questions, product questions, and also if you want to share your experiences working with this type of technologies. I'm enthusiastic about this, and I'll be happy to talk about it. Thank you very much. Hope you enjoyed.